Hey, Algebra 1, we're back. This is QM6, creating and solving compound inequalities. We're going to do this in two parts. So let's go ahead and get started. Again, this is QM6. Creating and solving compound inequalities. I can create and solve compound inequalities. So we're going to start with this. These are called truth tables. And in computer science, these are very important, but it's also going to kind of drive the point home of what we're trying to do here. So we've got this business. It says a compound statement is formed by combining two or more simple statements. A compound statement can be true or false. We also call this a Boolean, but don't worry about that. A compound statement involving and is true when both simple statements are true. A compound statement involving or is true when either one simple statement or both are true. So let's go ahead and look at these things. We're going to complete the truth table here. It says this is the P column and this is the Q column right here. Okay, so we've got a dog is a mammal. Is that true or false? That is true. Red is a color. That is true. And we're looking for and is true when both are true. So since these are both true, P and Q would be true. Let's go with this. We'll just fill this out. Dog is still a mammal. A dog is not a fish. Got that in here. Red is not a color. That would be false. Red is a color. That is true. Red is not a color. That is false. So we look at that second one. We have a true and a false. In order to be true for an and, they both have to be true. That makes this false. And then this one false because at least one of those is not true. One of those is false. And the bottom one, they're both false. So false. P and Q is true when both are true. Whoa, that's a bad one. Are true. All right. Let's look at an or example. Let's look at an or example. Okay. Complete the truth table. 1 is an odd number. True. 2 is an even number. True. 1 is an odd number. That's still true. 1 is even. That's false. 2 is odd. That's false. 2 is even. 2 is odd. For or, when we're doing or statements, just one of those things has to be true. Well, they're both true up here. P or Q, is that true? Yes. For the second line, true and false. I'm sorry, we have a true and false there. But if it's or, is one of those things is one of those two things true? Yes. So that makes the or statement true. Is one of the statements true here? Yes. But then the last one, they're both false. So just for an or statement, one of them has to be true. P or Q is true when one statement is true. When one statement is true. Okay, we're not going to do this part. We're going to go on to the meat of what we're trying to get to. So the first one we're going to look at is called solving compound inequalities involving ands. Ands. Combining two or more simple inequalities forms a compound inequality. The graph of a compound inequality involving and is the intersection or overlapping region of the simple inequality graphs. Ands go in. Ands go between. Ands don't have arrows pointing out. Ands go between. The words say all real numbers greater than 2 and less than 6. There's two different ways to write this. Notice for ands, you'll either see one of two things. For ands, you'll either see the word and, or you'll see this really cool thing down here. I love these. Love these. They make so much sense once we practice them. But you got to practice them. The second one would be all real numbers greater than or equal to 2 and less than or equal to 2. So in other words, numbers greater than 2 but less than 6, and they can also be equal to. That's why we've got these filled in dots at the end and going in between. Example 1 says solve each compound inequality and graph the solutions. Now, I don't like how they do this. I like doing it a different way. I like how they do it in part B. I'm going to show you both ways though. 4 is because, well, you might like this way. 4 is less than or equal to x plus 2, which is less than or equal to 8. You can split this up. This would be one statement. 4 is less, so 4 is less than or equal to x plus 2, and x plus 2 is less than or equal to 8. So we made 2 inequalities here, 2 of these statements. And we're doing the same thing. We're going to solve for x, subtract both sides by 2. 2 is less than or equal to x. Again, like we talk about, we really, really like it when we have the variable on the left. This is the same as x is greater than or equal to 2. And over here, we subtract 2 from both sides. We end up with x is less than or equal to 6. Well, let's graph these two things. This one on top is x is greater than or equal to 2. The second one in the middle here, this is x is less than or equal to 6. And here's how this works. It's the overlapping regions right here. These overlap between 2 and 6, including 2 and 6. I want to show you a different way for this one. 4 is less than or equal to x plus 2, which is less than or equal to 8. You've always heard me say, when you do something, you have to do something to both sides of the equation or inequality. In this case, I'm going to start using all sides. You need to do something to all sides. If I'm trying to solve for x, this is x plus 2. This is x plus 2. So if I'm trying to solve for x, I need to subtract 2. Well, I'm going to subtract 2 from all the sides, from over here and from over here. This is 4 minus 2. This becomes 2 is less than or equal to x, which is less than or equal to, 6. And here's how this works. Think about it like this. It even shows you x is somewhere in between 2 and 6. And since it's or equal to on both of them, they're both closed dots. It could equal 2, it could equal 6, and it goes somewhere in between. X is somewhere in the middle, in the middle of those things, somewhere in between those things. That's how we do that. Let's look at part B. Yeah, I like this one better. -5 is less than 2x plus 3, which is less than 9. Now, if I'm trying to solve for x, the first thing I'm going to do, if this was a two-step equation, you tell me, Mr. Brayman, subtract 3 from both sides. In this case, subtract 3 from all sides. So subtract 3 from here and here and here. And if you do that, you get -8 is less than, well, this is just 2x now because that's gone, which is less than 6. And you say, Mr. Brayman, how do I solve? Oh, yeah, it's 2 times x. The inverse operation of multiplication is division. I'm going to divide all sides by 2. -8 divided by 2 is -4. 2x divided by 2 is just x. Fantastic. Now we got x by itself. And 6 divided by 2 is 3. I'm not going to do this part. I like my way so much better that I'm going to ignore that. I'm going to tell you, we're going to put at least a dot at 4 or -4 and a dot at 3. This one at -4 is going to be closed because it's or equal to. -4 with a closed dot. +3, this is going to be open because it's just less than. And because x is somewhere in the middle, it's somewhere in between these two things, I literally just draw in between these two things. There's no arrows in this case. That would be the overlapping regions. Again, if you like the boxes, subtract 3 to then divide by 2. It might show up. Subtract. There we go. Okay. Those are how we take care of ands. I love ands. I love the way that this looks and this functions. It's just so nice. It's just so nice. Okay. Now it's your turn. Now it's your turn to give it a shot. Solve and graph, and you need to show me the work. You need to show me the algebraic work, or else this doesn't work. Okay, hit pause. There will be a pause also in the video for Edpuzzle. Then come back when you're done. Fantastic. I have in this first one, -2 is less than x minus 3, which is less than 5. If I'm solving for x, the inverse operation of subtraction, yes, you are correct. It is addition. I'm going to add 3, not to both sides of an equation or inequality, but to all sides. All sides. Add 3 here, add 3 here, and I end up with -2 plus 3 is 1, which is less than, now we're just got to x, which is less than 8. This is an and goes somewhere in between. This is beautiful. At 1, I'm going to put an open circle because it's just less than. At 8, I'm going to put an open circle because it's just less than. And this is telling me x is somewhere in between these. So we make x somewhere in between these things. Love this. This is one of my favorite targets that we do. Number 4. I have -10 is less than 3x plus 2, which is less than or equal to 8. Well, I know that I'm going to do this. I'm going to subtract 2 from all sides. And I get -12 is less than 3x, which is less than or equal to 6. Almost done. Got to get x by itself, divide everything by 3. I end up with -4 is less than x, which is less than or equal to 2. Here we go. So at -4, I'm going to put an open circle. And at +2, I'm going to put a closed circle because it's less than or equal to. And since it's an and it even shows x is somewhere in between these things. X is somewhere in between these things. Now we graphed it. I love this, love the compound inequalities. It's just so elegant. I don't know, there's something about it. I just like it. I like it maybe a little too much. I don't know. I like it a lot. Let's look at the other part. We did the ands. Now we're going to do ors. Ors. The graph of a compound inequality involving or is the union or combined region. In other words, we've got two different things going two different directions of simple inequality graphs. Think about this. Ands go between, both ors, not quite spelled the same, both ors. If you're trying to row, you don't put the oars in. Oars go out of the boat. Oars go out. Arrows pointing out. And you'll know it's an or because it will say or. You'll know it's an and because it'll say and or will have that compound inline inequality. Ors say or. All numbers less than 2, that's this guy, or greater than 6, that's this guy. Less than 2, open circle going left. X greater than 6, open circle at 6, going right. All numbers less than or equal to 2, that's this guy right here. Or greater than or equal to 6, that's this guy right there. Yeah, we got this. We got this. Let's see. You're saying, Mr. Bramer, what's this even look like? And I say, that's a great question. Let's find out what that looks like together. Oh, yes. I love ors. You're going to treat them separately. Treat the things separately. You're not always going to have the same -4 plus x, and we'll see what that looks like here. Our first example is -4 plus x is greater than 1, or -4 plus x is less than -3. Solve each one independently. So if I'm looking, again, I'll even do this, right? I'm going to solve for x by adding 4 to both sides. I get x is greater than 5. X is greater than 5 is this guy right here. If I solve this one, -4 plus x is less than -3, I add 4 to both sides and I get x is less than 1. Come over here to 1, less than 1 goes that way. This is what we're looking for. Ors go out. Ors go out. Let's look at example B. I have 2x is less than or equal to 6, or 3x is greater than 12. Keep them separate, one at a time. 2x is less than or equal to 6. To solve for x, I'm going to divide both sides by 2, which means x is less than or equal to 3. I'm going to just go ahead and graph that. It's an or. At +3, I'm going to put a closed circle, and less than, in this case, things that are less than are going left. That's that part. Now let's look at another one. Let's look at the other half of this. Or 3x is greater than 12. 3x is greater than 12. Divide both sides by 3. X is greater than 12 divided by 3 is 4. I'm going to come over here to 4, put an open circle at 4, and things that are greater than, we're going to the right. This right here is my graph. I've got my solution, and I've got my graph. I need both of those things. Okay, now we're on to the your turn part. We've got x minus 5 is greater than or equal to negative 2, or x minus 5 is less than or equal to negative 6. Treat them separately. Okay, we've got x minus 5 is greater than or equal to negative 2. To solve for this, I'm going to add 5 to both sides. X is greater than or equal to 3. Come over here to positive 3. That's a closed circle. Oh, I hope you guys hit pause, by the way. Hope y'all hit pause, then try them out. And then things that are greater than 3 go to the right. Or x minus 5 is less than or equal to negative 6. I'm going to add 5 to both sides. I get x is less than or equal to negative 1. I'm going to come over here to negative 1. Closed circle because it's or equal to. And things that are less than go left. Things that are less than go left. For the second one, we have 4x minus 1 is less than 15, or, ors go out. 8x is greater than or equal to 48. Treat them separately. I'm going to start by adding 1 to both sides here. 4x is less than 16. Divide both sides by 4, and I get x is less than 4. That's the first part. Come over here to 4. Open circle because it's just less than. I'm going to go left in this case. If I check 0, 0 is less than 4. I'm drawing that way. I know for this next one, my next arrow has better go to the right, because if it doesn't, I done screwed up, because ors go out. Divide both sides by 8. I have x is greater than or equal to 6. I come over here to 6, closed circle. And since it's greater than, numbers like 7, 8, 9, 10, that's greater than. So I'm going to draw my arrow this way. And there. I am good to go with that one. All right, here you go. That is the end of part 1. I'm going to go into part 2. I'm just going to split them up. I still want you to do them all on at the same day. We can do this though. All right. Part 1, that's the end. We'll come back with part 2.